So for my question, I asked, is there a correlation between weather conditions and the number of car accidents per year? And I will be comparing the number of car accidents in Oregon and the number of car accidents in the United States. So the frequency observed counts are for the number of car accidents in Oregon per year, and the frequency expected counts is the number of car accidents in the United States per year. And I looked at 3 different weather conditions: dry, wet, and snowy and icy. And then you can see the number of car accidents in Oregon is already in the table. So for my null hypothesis for this question is there is no difference between Oregon and the United States in weather-related car accidents. And my alternative hypothesis is that there is a difference between Oregon and the United States in weather-related car accidents. So next you have to find the expected counts, and you do that by adding up all the accidents in the observed counts, which is 5,958 plus 2,412 plus 1,853, which equals 10,223. And then so to find the dry expected counts, you do 10,000 times 223 times 0.74, because 0.74 is the percentage of car accidents in the United States during dry weather, and that equals 7,565.02. Next, you find the wet conditions for the expected counts, and you do 10,223 times 0.093, because that's the percentage of car accidents during rain in the United States, and that equals 950.74. Next, you do snowy/icy, which is 10,223 times 0.027, which is the percentage for accidents during snow or ice in the United States, and that equals 276.02. So now we need to put these back in our table, and that's what we have done. So next you have to find the test value and the p-value, and to do this you have to go into the stats list and then put in your data into list 1, which is the observed counts, is list 1. And the list 2, you put in the data for the expected counts, and then you go to F6, which you do by hitting second and then F1, and then you go to number 7, chi-squared GOF, and then you enter list 1 into observed and list 2 into expected, and then for degrees of freedom, it's n minus 1, which is number of categories minus 1, and since we have 3 categories, our degrees of freedom is 2. So we found out that a test value for chi-squared is 11,597, and you can see that on our graph. And then you can see the p-value is 0, and 0 is less than 0.05, so the p-value is less than alpha. So we reject the null hypothesis. There is evidence to claim that there is a difference between Oregon and the U.S. in amount of weather-related car accidents.